Okay. So question 7. Solve each of the following equations for 0 to 180 degrees. 3 tan 2x equals 1. Okay, so we've got 3 tan 2x equals 1. Notice we've got to always check what we're looking for in terms of the x values of these things. So there we've got x just between 0 and 180. That's quite important, isn't it, to look out for that first. So 3 tan 2x equals 1. We're going to go straight into saying, in a better pen than that, so that means that tan 2x is a third. And then we're going to do inverse tan of a third, making sure our calculator is in degrees mode, and get what that gives us. Anybody got that handy? The inverse tan of third. Sorry? Great, thanks for your feet are up on the chair now. It's okay, I can cope. 18.43. Was that right? Is that what we said?
I'm in radio.
Excellent. Now, we of course, we need a second value for this, don't we? So, depending on what your method is for doing this, you're either going to go to your tan graph. This is really uncomfortable for me to do it with the tan graph. Oh, that's horrible. There, which looks vaguely like that. This should be probably drawn better because you're not using a tablet. And you get 18.43 there. Your next value would be 18.43 after 180. So that would be your next value. Of course, if you're a better class of person and use the cast diagram, you would draw your angle like that. It was tan, it's positive, so 18.43 goes there, and it also goes with the horizontal there. And so you're going to measure your two angles as being 18.43 in the second one, starting at 0, going down to that point, gives us the same answer. 100, what is it? 198.43, that's right. Now, remember, we've got to consider which values we're looking for with this. With the cast diagram, we normally look at the number in front of x to work out how many times we're going to go around. But because it's just 0 to 180, we're only going to look, our final answer, 2x, well the 2x we're looking for is between 0 and 360. So we don't need to look any further than that, like we normally do with 2x. So we're going to adjust your domain to match up to the value of x. There we go, we've got those values. So finally we're going to halve them. X is 9.22. And the other one, which would be 99.2. degrees, and we've given both of our answers to 3 significant figures. Great, just 3 marks for that. Now, part 2 is a little bit trickier, isn't it? We've got 3 cos squared x plus 2 sin x minus 3 equals 0. Now, our first task is to turn this into an equation we can do something with. At the moment, we can't do anything with it because it's a cos squared and a sin x. They're not in terms of the same trig identity, not in terms of the same operation. So we need to think, can we change this to either all be in terms of sine or all in terms of cos? Well, the sin x we're kind of stuck with. We can't do much with the sin x, but cos squared x, we know from our poster, from having memorised it, that sin squared x plus cos squared x is 1. So if we rearrange that equation there, it says that cos squared x is 1 minus sin squared x. So our next move is to replace the cos squared x there with a 1 minus sine squared x. And to be honest, it's a fairly standard kind of equation, this, isn't it? We ought to have practiced lots of these. If you look through the past papers, there are lots of equations that start with either cos squared and a sine, or sine squared and a cos, and you have to change them to get them in terms of the same thing. So now this is starting to look like something we can work with. We've got 3 minus 3 sine squared plus 2 sine x minus 3 equals 0, which if we collect like terms together, we actually end up with minus 3 sine squared x plus 2 sine x equals 0. Now, I find I often prefer to have the coefficient of the squared term as being positive, because it makes things a little bit easier